Okay, today we're going to continue with our rational function graphs, and what we're going to be looking at today is sort of restrictions or parts of the graph that don't exist. So we already know from the last topic that we have asymptote lines. So in this case, we've got a vertical asymptote line and we've got a horizontal asymptote line. So those show up, but we can see here on this graph, it might be hard to see, we actually also have a little hole in the graph located there. So that's all we're looking at today, is just what are the restrictions, what are these asymptote lines, and other areas of concern. So we know that from a rational, because we're dividing by x, we're going to get non-permissible values. So that means we get asymptotes, or those little bullet hole things are what we call points of discontinuity. And we need to be able to figure out what they are, where they are, those types of things. So we'll start with asymptotes. The first thing is, if the denominator has a non-permissible value, we normally think of it as being an asymptote. So we know from a previous section, we have x minus 1 on the bottom. We know x can't equal 1. So that means that's where our asymptote line would be located. So that's true in most cases, but we have to be careful that that'll only happen when we can't cancel that denominator out. So what that means is if our top and bottom have different factors, then we would get an asymptote line. So what we normally would do is look at the equation. So if we look at this example at the bottom, we have a top and bottom is different. So that means we will have an asymptote line. We know that the vertical asymptote will be at x equals 3. And then if we want to calculate the y asymptote line, remember what we want to do is switch it to our other form. So let's quickly review that. So we'd write this one as 1. There's 1 in front of x. We'd have 1 times x minus 3 over x minus 3. Plus, and our magic number would be negative 3. We want it to equal 4, so we'd have to add on a 7. So then our equation would be, once these cancel, we'd have 7 over x minus 3 plus 1. So in this case, our y asymptote line would be at 1. So asymptotes work the same as we were doing yesterday, nothing different there. But what is different now is when we have points of discontinuity. So a discontinuous point will occur when that top and bottom, or the bottom non-permissible value can actually be canceled out. So if we look at this example, we have x plus 2 on the top and bottom. So we could actually cancel those out. So our graph would simplify to just y equals x minus 4. Well, that graph is just a straight line like I've got shown, but we still know that x can't equal negative 2. So we just show that up as a little bullet hole on the graph. So that's this original equation then is exactly the same as x minus 4, except we don't have a point that exists at negative 2. So typically your graphing calculator won't show that, so we just have to understand it manually so that we can draw that in if need be. And worst case scenario, you're going to get a question that has both, so you just have to make sure you're aware of both. So if we look at this one, we see we have x plus 2 that would cancel. And we have an x minus 1 that doesn't cancel. So that means we have a vertical asymptote. And that'll happen when x equals 1. And then we'll have a point of discontinuity. Oops. Big words to write down, but I'll just write discontinuity. So discontinuity point will be at negative 2. So we know, if you look at this graph, if I actually graph the graph, we see we get our asymptote line at 1, and we've got our little bullet hole at negative 2. And if we needed to get the horizontal asymptote line, that's where we'd have to change the equation. So what we want to do is change the equation of the simplified version after we canceled it. So in this case, we'd write it as 1 times x minus 1 over x minus 1. And we would have, that gives us negative 1, we want negative 4, so we'd have to subtract 3. So in this case, we'd cancel these out. So we'd have minus 3 over x minus 1 plus 1. So you can see just from the equation, the negative 3, remember, is vertical reflection, so our graph is backwards. And we have our asymptote lines at 1 and 1. And we can actually see that the 3 is a 3 times, so we go over 1, up 3, that actually gives us our correct coordinate. Or if we go over 1 and down 3, that gives us the correct coordinate. So the graphing part of it, everything's still the same. The only thing that we're sort of adding on differently now is how to get that discontinuity point. So let's try another one. And this is probably the hardest type of question you'd get, where you're going to have to do some factoring first. So if we actually factor the top, The factors would be minus 4 and plus 1. So once we factor that, we can see the x minus 4's would cancel. So our equation ends up being y equals x plus 1, but remember x can't equal 4. So if we were just to graph y equals x plus 1, we would get a straight line, something like that. And we know that at 4 it doesn't exist. So if we wanted to know the exact coordinate, let's just put the 4 back into this equation. So put 4 in, you'd get the coordinate of 4, 5 would be our discontinuity point. So if we look on our graph, 4, 5 is right about there. So we just put that as a bullet hole and we're done. No asymptote lines because the bottom canceled out. So here's another one, looks kind of the same. So if we factor the first equation, we would get x plus 3 and x plus 1 over x plus 1. So those would cancel. So our equation would be just y equals x plus 3. So that'll just be a straight line, sort of like that. And we know that we have a discontinuity point at -1. So at -1 and 2 would be where we're discontinuous. So that's the first equation. So we'll do the second equation. I'll do this one in red. So we factor the second one, we'd have x minus 3 and x minus 1 would be our factors over x plus 1. So in this case, there's nothing that cancels. So in this case, we would have a vertical asymptote at -1. And we just have to draw the graph, and if I remember right, it looks something kind of like that. And that's it. So obviously they're two different graphs. Even though they look the same, that one having a plus, one having a minus makes a way different graph. So the first one ends up being like a straight line with a discontinuous point. The second one is just a regular kind of quadratic type of graph that has a asymptote line. Okay, one more to go. Let's look at this one. So if we factor the top, we'd have x plus 4, x minus 2. Factor the bottom, we have plus 4 and plus 1. So we can see in this case we got a discontinuous point at plus 4, and we have an asymptote line at -1. So if we put our plus 4 coordinate into the original, or into this new version, so we'd have 4 minus 2, which is 2, over 4 plus 1 is 5. So we should get 2/5 would be our discontinuous point. And we'd have x equals -1 would be our asymptote for our horizontal. And let's switch the equation while we're at it. So let's change it to 1 over x plus 1 times x plus 1. So that gives us 1. We want -2, so we'd have to subtract 3. And let's rearrange that equation to the other form. So we'd get -3 over x plus 1 plus 1. So we already know that our x-intercept, our x asymptote was at -1, but we also get a y asymptote at +1. So we have all of our key bits of information. So let's do our x asymptote at -1, our y asymptote at +1, and if we draw our graphs, we know we have a -3, so it's going to go backwards. So let's go 1 over 3 up, 1 over 3 down. So our graphs will do something like that. So there's our graph. And the only thing we forgot was our discontinuous point. So 4 and 2/5 would be right there. And that's it. So you can see it's pretty much the same as yesterday, just add on those extra discontinuity points, and that's the only thing that's different.